Hello, everybody. How's it going? Welcome. Thanks for being with us here on Thursday afternoon. I'm Mandy Whaley. I lead our Azure DevTools team, and we build SDKs, tools for agents, all kinds of things to help you build apps on Azure and Foundry, and to make your job easier. And I'm really excited to be here today with my friend Nir.
Hello. I'm Nir. I'm the guy who has to wake up in the middle of the night when there's no code bugs coming from here. So I run a bunch of properties of Platform as a Service and our Azure SRE Agent service.
So we're really excited to be here today. We're going to help you ship faster and stress less using Azure and GitHub Copilot together. So agents are now available to help you across the whole software development lifecycle, from helping you create your code in your IDEs, to collaborating with you and your teammates and working in your repo on async issues, to helping you operate, monitor, and maintain your application. And this is what we think of as agentic DevOps. There's really key three ideas within this topic. One is about moving from AI-infused to AI-native. And this is that idea that you have the agents embedded into your workflows, into your tools, across that whole lifecycle. And that, in turn, increases your productivity across the whole lifecycle, which helps you accelerate your ability to deliver AI apps and agents. And so our team is working really hard to make sure that when you are building on Azure and Foundry, you have the best tools to work with all of the agents across that lifecycle. When you're coding, you can use the Azure MCP Server in VS Code and Visual Studio. Building and maintaining, you can work with the coding agent and use the Azure MCP Server there as well. And then in the operate phase, the SRE agent is there to help keep an eye on your app, help you identify issues and fix them. We're going to deep dive into each one of these and look at some of the tools and the way that you can use Azure and all of these tools together. We're going to start off with code. So you can make any agent an Azure expert with the Azure MCP Server. The Azure MCP Server brings tools to the LLM that give it your Azure subscription and context on your resources, your best practices, how you use Azure. It also always has the latest documents on Azure, the latest libraries, and best practices baked in for using things like managed identity and helping you secure your application. It also has tools that the LLM can use to access Azure and Foundry services, both control plane and data plane operations. And then there are ways that it can help you with your application deployment, as well as writing and managing your infrastructure as code assets. And then it also helps you with Azure CLI tools to just do all kinds of handy things throughout your workflow. And we'll see some of those examples today. You can use the Azure MCP Server in VS Code and now in Visual Studio, which we just announced this week, and it ships in the box with Visual Studio 2026. You can also use it in any IDE that supports the MCP protocol, like IntelliJ, the coding agent in GitHub, and also the new Copilot CLI. You can also use it to build your own custom agents as well. So we're really excited to announce the GA, General Availability Release of the Azure MCP Server this week at Ignite. We now cover 47 different Azure services, and that list is constantly growing. You can see from the list on the right, it covers everything from your Azure Resource Management, diagnostics, monitoring, compute, data services, and the list keeps growing. Everything is secured with Azure Identity and just works like you normally would through your dev tools. You can check it out at the links below, and we'll have some QR codes and things later in the slides as well. But next up, we want to take a demo. Take a deeper look in a demo. All right, so I'm going to start in VS Code, and I have the Azure MCP Server installed, and I'm going to take a look at all of the tools that are available to agent mode in VS Code. You can see I have Azure MCP, and when I expand that, you can start to see the list of the different kinds of categories of tools that it provides. You can select the ones that are most relevant for what you're working on. You can even build custom tool sets and custom chat agents. For this, we're gonna use the full set, and we will try out a few different commands. So one of the really great things about it, like I said, is it's easy to help you discover Azure services, get the latest docs, find recommendations. So we're at a show, we might take some cool pictures. We may want to know what's the best way to store photos in Azure, and it's recommending Azure Blob Storage. I also can use it to actually take a look at my deployed resources. This one takes a little bit longer to run, so I'm just going to start with it in the interest of time. So in this one, I'm asking what AI models do I have deployed, and I also want to group them by region and by the model. You can see in the chat context where it's actually using the Foundry capabilities of the Azure MCP Server. It's getting our resources, and then it returns this great list of all of my different models that I have. I have GPT-4, GPT-4 Mini, 4.1, and it also lists the region like I asked for it. And this works with any of your Azure resources. So you're looking for where's the storage account, what is the URL for my website, how do I get a direct link to the portal, to the resource group that I'm working in. All of those kinds of queries you can do through the Azure MCP Server and Copilot. So another great one is you can actually have it do things for you, like create storage accounts. So in this one, I'm going to ask it to create a new container that I'm going to store our photos in for this Ignite. This is going to do the same thing. We can see it start working. It begins to invoke the Azure MCP tools. It's going and using the storage tool. And we'll see that it's learning about what capabilities it has. And then it starts to invoke the appropriate tool to actually create the container. So we'll wait, and hopefully the network speeds up. Yep, excellent. So it created our storage container, gave it the name we wanted, and I also specified that I wanted the public access turned off. Now, another thing that is really useful in your dev flow with the Azure MCP Server is that it can help you write code, and it can help you write it with all of those Azure best practices baked in. So in this case, I'm asking to create a Python script that will upload files to my storage account. I'm telling it which container I want it to go in. I want it to handle errors gracefully. I want it to use managed identity and connect in a secure way. So in this case, it does use our best practices tool to get the best practices for doing that securely. It starts creating it. We can see that it's using default Azure credential. It's not hard coding in any keys. It's following our security best practices. And if we take a look at the code, we can see those things that it created. So it's using their Azure SDKs. And then we can see where it's using default credential as well. So that's a really great way. It gives Copilot the best information about how to write your code that interacts with Azure. And then one other favorite use case that is highly used and requested and always improving is helping you write infrastructure as code. So in this case, I'm asking it to create the infrastructure as code to provision in Azure Container Apps, something that my friend Nir works on. And in this case, we can see it's going out, it's getting the best practices. It's also looking at Azure verified modules. I don't know how many of you use Azure verified modules, but it's a great collection of kind of pre-baked best practices in Bicep modules that you can use. And we use that as a reference in the way that we create the infrastructure as code. And then it's creating the Bicep files. Same thing works for Terraform, so you can use either one. OK, we are going to head back to the slides and continue on. So next up, we're going to build an application. And we're going to use a really powerful workflow that I encourage everyone to try it out. I think this workflow combines VS Code, GitHub Copilot, the Azure MCP Server, and a project called Spec. Spec is a really new, exciting project from GitHub. It helps you create specifications for what you're trying to build that are very well suited for the LLMs to work from. So it breaks down the task, it gives the requirements, helps you create the structured tools for that. So you can get Spec from the repo, and we're going to take a look at some of the examples in using it. And there's two commands I want to call out before we dive into it, because they kind of set the stage for what we're going to be doing with Spec. One is the constitution command. This is where you can tell Spec, these are the things I want to be always true about my application. These are kind of like your preferences, your personal best practices, the things you want it to follow. So for me, I'm telling it, use the Azure MCP, always check best practices. I'm going to be hosting my app in Azure Container Apps, and I always want to use managed identity. You could expand that to cover whatever kind of compute services you want to use, other things that you want to be true about how your app is built. And then specify, this is the command where you actually describe what do you want to build, and you start to spec out the capabilities. So we're going to build a website. It helps people locate fitness studios and trainers. And so this is an example of our where we start. OK, let's go back to VS Code. All right, so we are going to start with the Constitution. So this is the view where I created my Constitution. So I have SpecKit installed. I have the Azure MCP installed. When you install SpecKit, it gives you really great little shortcuts for running these SpecKit tools, like the Constitution tool. So I'm giving it my starter. And once it does that, it starts creating the Constitution. And then we can take a look at what it created. It creates a really nice markdown file. It takes those short sentences I wrote and turns them into more specifics that the agent can follow. So it's talking about my Azure architecture that I'm going to deploy using AZD, that I'm always using the Microsoft Agent framework to build my AI agents. So that's what we're going to be building in the application. So we also have published an example Azure Constitution on GitHub. This link is in the slides. You can get it. You can start from this to build up your customized Azure Constitution if you're using SpecKit. So this can start to show you all the different things that you can do with that. All right, now let's take a look at the app that we're going to build. So here is the app that we're building. It's a website that lets you browse the different studios and trainers. It's got a page for the fitness studios. You can dive into the details. There's the list of trainers. And it also has an AI agent built into it that can recommend activities. Like, I want to do, I can't type, yoga. And so it's going to look for the database of trainers that we have and actually recommend the ones that do yoga. So a pretty full-featured app. I wrote this app for this demo using SpecKit and Copilot. I did not write any of the code by hand. This all came from the specification and through the steering of the requirements that we gave it. So pretty powerful in terms of the full-featuredness of the application, including the AI agent. All right, so really quickly, we're just going to run through several of the different steps that you would go through to build the application using this workflow. So we already did the Constitution. Here is our specification. This is where I start what I told it about what I wanted to build. Pretty high level. I wanted to have categories. I wanted to have trainers and studios. I wanted to have the AI agent that can actually recommend things, and a little bit about the pages and navigations that I wanted to have. And so from that, SpecKit will create the spec. And we can take a look at that. So you can see it starts to really go through and build out user stories, start to talk about how you would specify how you would build this application in a real way. And this turns into great instructions for the LLM to act on. Now, my next feature of SpecKit is my favorite. This one is called Clarify. And so when you use Clarify, what it does is it will look at the spec that it created and the Constitution and all the information created so far. And it looks for anywhere that there are ambiguities, things that you might be missing, things that it needs more information on to succeed. So, and then it brings those back as questions. So here it's saying, I'm not clear about the relationship between the trainers and the locations, and how do we want to do that? And then it gives me some options. I can answer it. It goes on. It edits the spec and updates it. The next one is more of a functional requirement, asking about a performance requirement that we had and how to treat it if that fails. It does the same thing, updates the spec, and moves on. From there, it creates a plan. This is like how it starts implementing it. It starts picking actual technologies based on your Constitution and the requirements. And then we can see where it starts to do some of the implementation in the task. The task is like how it breaks up the work. And typically what it does, it gives you a lot of checkpoints to check in on what it's done. Is it working? Test it locally if you want to. Places where you can interact and steer the implementation. And then there is the, there we go, the implementation of the back end. And so here we can see when it starts implementing the back end, it's starting to use our Azure MCP Server tools again. It's getting the best practices. Here it's using some of the Foundry tools to get information about how to build the agent and sample code for building AI agents using the AI agent framework. And then it starts implementing all of the pieces. The last step is to deploy. And because, once again, that was in my constitution, it knows I want to use AZD. It starts to do a checklist of what it needs to be able to do that, and that includes creating all the bicep. And at the end, it lets me know everything's ready. It's ready for us to move on and start deploying. All right, so that was a quick view of the Azure MCP Server and Spec Kit. This workflow is amazing for all kinds of apps, not just web apps. Could be any kind of app. Definitely encourage you to try it out. You can get those tools from these QR codes. So the Azure Tools extension, that will give you everything you need in VS Code to be successful on Azure. It includes the MCP server, also includes all of our extensions for app service functions, container apps. If you get that extension pack, it stays updated and you always have the latest, greatest tools. And then Spec Kit, that's a repo. You go there, you get the tool and start it out. Here's an example of a starter constitution prompt for building your Azure constitution. And you can also get the one that we posted on GitHub. OK, and one real quick announcement. Just wanted to remind everyone that the Azure MCP Server is available in Visual Studio 2026. It's generally available. This was a huge request at Build, and we're really excited to make this available for everyone at Ignite. So check it out. OK, we're ready to move into Build and Maintain. And in Build and Maintain, we're starting to work with the coding agent. The coding agent works asynchronously. It's like another dev on your team that you can assign issues to, and it will work asynchronously in your repo. And that's great. And what we can do with the MCP server is we can configure it so the coding agent has access to all of the Azure tools we just looked at in VS Code the way we were using them. You can specify which tools it has access to work as it works on issues in your repo for you. We also have a new command, AZD coding agent config. This helps you set up the connection between the coding agent and the Azure MCP server securely. It walks you through all of the identity steps to get it set up correctly and securely. So really great, easy way to get that configured and going. We're going to take one really quick look at this. Oh, sorry. OK. So this is what, here's an issue in my repo that I created. It's to create sample data for more trainers. And I just want to show you what it looks like when I start interacting with the coding agent. So here I can choose to assign this issue to Copilot. And then because I have configured the Azure MCP server, and I also use this feature to create my own custom agent. So I created an Azure agent that knows to always use the MCP tools and gave it some prompts and things that it can use. So I can assign this issue to this custom agent, to the coding agent, and it will start to work on it in the background and then give me a pull request that I can review. All right, next up, we are going to move into Operate, and Nir's going to take us through the SRE agent.
Thank you, Mandy. So we operate massive amount of services. On our team, we have App Service, we have ACA and Azure Functions. Together, that's something like 5 million VMs. You can imagine that we have a lot of tickets and we have a lot of support calls. And I know how many of you have to wake up at 2 a.m., go and look on some dashboard, wait for the graph to go back down, and go back to sleep. And that's expensive and somewhat demoralizing. So about a year ago, when this AI thing became big, I don't know what's that about, we decided to try to automate some of these activities. And we started building SRE agents for ourselves. One reason was to save with resources and costs, but the other one is we're trying to be the best platform to host your agents, and we might as well build one and figure it out. So that sort of started us down the journey. All you're going to see today has been used by Microsoft engineers for the last 9 months. And all of the features we announced this week have been tried internally, and I have a slide with some of our stats on what type of savings we got out of it. We definitely ended up not in the place where we thought we were going to start. We thought we were going to have this amazing agent that is sort of omnipotent, and it will look at everything and will just say, hey, this is how we solve your problems. And what we realized that what teams and engineers want, they don't want a replacement, they want someone to just help them. And all of us have a bunch of business processes and the way we treat our tickets and the flow of our tickets sort of enshrined in our organizational knowledge bases or in people's heads. And what the SRE agent helps us to do is very quickly automate that tribal knowledge. So with that, we have several features. We can now take documents and upload them into the SRE agent for your knowledge base. We can directly connect to the Azure DevOps developer wikis, so you can take knowledge, again, that you have there and give it to the agent. We have native incident management. We will show a bunch of that in the demo. But basically, you can use third-party tools or your own tools to initiate these events. So instead of you having to wake up, the SRE agent wakes up. The SRE agent can, with our sub-agent features, is able to take all of these disparate data, right? You want to query this, query that, and look at some other stuff, and it goes and enriches the ticket. So if and when we have to wake up the human, they have all the information they need to, instead of going to sort of 5 different screens of queries to figure out what's going on. We also designed it with an eye to our third-party customers. All of you use different tools in your own unique way. In Ignite, we announced MCP support. So basically, now you can consume data from anyone who supports an MCP, like your Dynatrace or New Relic, where a lot of your data is sitting, but also the know-how of what constitutes a downtime from your perspective. And we also have agent-to-agent integration with Newbeard, who's a SRE agent vendor as well that works cross-cloud, and with PagerDuty that we will show today. So some internal numbers. So these are sort of last 90 days. We handle this amount of tickets. That doesn't mean that we solved all of them, but we touched all of them, enriched a bunch of them. We are calculating each ticket to take about a few minutes if you have to do it yourself to collect all the queries and the data. Some of them will take you up to an hour. And this is kind of a calculation to how many hours we saved. So there's significant savings in time and allowing our engineers to focus on value-added work and on training the agent to be smarter about other types of incidents so we can do the deep analysis or plan the architecture for the next generation. And 95% initiated via automation. It means that the agent is listening to these tickets come in and going and fixing them. Cool, so Ignite is a big release for us. As we said, all of these features were tried internally. What we found out, which was the big kind of learning, was, again, people don't want an agent that is a black box and just sort of does stuff and gives you a recommendation. They want to be able to build their own sub-agents. So we added a sub-agent builder. That sub-agents allow you to override our meta agent, if you will. So if a type of incident comes in or if a timer expires, you can run your agent. Your agent can supersede the Microsoft agent and go and do these activities. And you're able to connect tools to this agent that are in your scope. So for example, again, you use only Custo or App Insights, so you'll add the Custo tool, the App Insights tool to your agent. The other thing it does, it allows you to communicate outside. So we have connectors to Teams and to email, so you can have your agent wake up, do some kind of scan of your health, and send you an email and tell you what's going on every morning. So this is sort of what we heard from customers. They want the transparency to understand how it works. The other very cool feature is we have the debug trace view. So when you build these sub-agents, you're not starting from scratch. You're starting from a bunch of samples that we have, and you can use the debug view to sort of improve your prompts. So you can run it in test environment until you're happy with it, and then it goes into production. I mentioned scheduled tasks. With scheduled tasks, it's no longer a proactive agent. It could be it could actually have its own schedule to do stuff. So again, you can go and say, OK, I do my releases every Wednesday between 4 and 10 for those of you from the good old enterprise world. So at 11, I want to run all these scans to make sure everything is still legit and still running. So now I can go schedule that. The other thing, again, that we heard from customers is that they wanted to bring their own know-how. So that's available to file uploads, to integrating with Azure DevOps wikis, and by bringing your own MCP server. So if you have your information in Jira or Confluence or something like that, everyone has an MCP now, so you can go and get that data in, and you can go filter these queries the way you want to. So with that, with that, I'm going to invite Dheeraj to show us all of this in action. Thank you.
Awesome. Thank you, Nir. So we're going to go ahead and look at what we're building with today. I want to quickly go through the diagram because we're pulling together a lot of different things here. So welcome to the modern SRE stack. We begin by having the Azure Container App that Mandy just deployed as the Java Fit application, all the way over here on the left as number 1. We're going to have it crash, which is going to end our live site availability. We're going to have an incident open up in our wonderful integration with PagerDuty. It's going to detect this incident and send that incident to Azure SRE Agent. Now that the incident is detected, SRE Agent will be able to begin an investigation. But to begin an investigation, we need to make sure we have logs and information from the builders. So we're going to use Datadog via Azure native integration for Datadog and the Datadog MCP server, along with Azure Monitor logs and PagerDuty SRE Agent to receive an AI-generated runbook based on prior incidents. With this information, the Azure SRE Agent then performs a mitigation to reduce downtime. And then it also opens up a GitHub issue to perform a long-term remediation that will be completed by GitHub Copilot. So we're going to go ahead and switch screens here. We can see this is the same app that Mandy was showing earlier. But now on my Studio's endpoint, I'm getting this 500 error. We're unable to see the studios that previously were available for whatever reason. Obviously, not great. I'm going to go to my PagerDuty portal here. We can see that an incident has already been created. Agentic Azure DevOps backend container app is throwing a 500 error, and the details are, it's not responding. So we have to look at the details. P1 incident, it was released, it was assigned to me. Perfect. This is something we all see. But instead of myself personally responding to this immediately, I'm going to go ahead and use the Azure SRE Agent. So first things first, I'm going to make sure that my logs are flowing to Datadog. This right here is our portal blade for the Azure native integration for Datadog. One of the cool new things that we have released is the ability to not only flow logs to Datadog via Azure, but also to enable SRE Agent and the MCP server associated with that Datadog directly from this portal blade. So I can just select any SRE agent that I have and add the MCP server directly from here. It just makes the experience a lot simpler, and we're really excited about it. But for the sake of this demo, I've already added the MCP server to my SRE agent, and my logs to Datadog are already flowing. You can see here I have my application level logs. You can see error retrieved, studios 500, there's a memory threshold issue, et cetera. I have these all at the application level. Over here, my Azure level logs, so the infrastructure platform logs, are also being flowed to Datadog. Now, this right here is the Azure SRE Agent. And what we do in Azure SRE Agent is pull all of the tooling that I just showed you, PagerDuty, Azure Container Apps, as well as Datadog, and we put it all together and instruct SRE Agent to use these tools to remediate the issues. The way we do that is with our brand new sub-agent builder. It's a little small, so the details might be hard to read, but what I've done here is I've created a Datadog sub-agent that uses the MCP server and the tools available in that MCP server to remediate these issues. I'm able to write the instructions for how the subagent should act. For example, it should fetch telemetry like logs and metrics and traces. I also add handoff instructions. I want it to be handed off to this subagent whenever a user instructs, wants Datadog is mentioned in the user prompt. Finally, I've instructed it to use the following tools. The Datadog MCP connectors, these are all the Datadog MCP server tools like get Datadog logs, search Datadog logs, and search Datadog metrics. Similarly, we have the PagerDuty SRE agent subagent. Again, this is something I've built as a customer of SRE Agent. I have the instructions, I have my handoff instruction, and I also have the tools that I want used by this subagent. What this allows me to do is it allows me to control how my incident response happens. I'm ensuring that the tools that I want used are the ones that are used when this PagerDuty incident is opened. We're going to jump into the actual how these subagents end up working. So you can see here, I'm able to call via the @agent command in SRE Agent. I'm able to call the PagerDuty SRE Agent. For the sake of this demo, I've already called it. And we can see I've asked it to generate a runbook for my specific incident ID. And I've also asked it to find my assignee, so I know who is responsible for fixing this moving forward. It tells me it's going to generate the runbook, which should be very important, as that's what I wanted to do. And we can scroll down here. And we can see this is the runbook that I've asked for. It provides me a step-by-step troubleshooting guide, mitigation steps, post-mitigation verification, rollback guidance, and the assignee. It is also already, without any further prompting, has added the runbook back to my incident in PagerDuty in order to provide that information as context to itself in the future, as well as any other responders to incidents on this service. Now, this is important because what we're doing is we want to meet customers where they're at. If their data is stored in PagerDuty or Datadog or Dynatrace or any of our partners, we want to make sure that the Azure SRE Agent has context to that data without additional work from our customers. So all of that data is here now. It also asks me if I want to set up a short watch to verify error rates and latency, so we'll get to that shortly. First, I wanted the PagerDuty SRE Agent to also export it to a PDF file. Just for fun, I want to share it with my team, email it around. And it generates this PDF file for me with the same step-by-step troubleshooting, mitigation steps, post-mitigation verification, rollback guidance, etc. Going back here, in a separate thread, I also wanted to leverage the Datadog MCP server. In this thread, what I asked the @agent Datadog MCP server to do is I ask it to provide me all the Datadog logs that are relevant to this PagerDuty incident. It's able to do that and give me also the ability to set up a scheduled task. Now, a scheduled task in this particular case is to query Datadog logs for every 5 minutes for the next 2 hours to look for similar errors that might occur. This is nice because once the SRE agent is able to do its mitigation, we want to verify that the fix that was made actually works. You can see here, these are all of the 500 errors and requests that are made that are pulled via Datadog MCP server. And over every 5 minutes, it's able to pull these logs to ensure that there are no further issues that are created. We can also track all of these scheduled tasks, as well as create new scheduled tasks for any of these tools that we're working with on the Scheduled Tasks tab. This is brand new. We're super excited about it. You can see here you can turn these scheduled tasks on and off as necessary. You can keep track of how many times these tasks are run, etc. Finally, we put all of this together, and this is the final incident remediation that the Azure SRE agent is able to do. We start with the PagerDuty incident. It's reported here. You can see all the details. It was Azure Agentic DevOps through 500 errors, severity. The Azure SRE agent is able to generate these custom instructions that can be edited moving forward as to what it wants to do in order to resolve this. This can range from tools it uses within the container app, as well as looking at the GitHub repository code, everything like that. We're going to scroll down here. It acknowledges the incident, and it starts to investigate. It uses AZCLI to look through the container app logs. It's able to find the container app logs, and it's able to generate this visualization. It finds that there were a bunch of 500 errors in the last 30 minutes, and that's what they look like. It runs a correlation analysis to figure out what other issues might have happened at the same time to give it a better understanding of what it needs to do. It finally understands that maybe to mitigate this in the short term, we need to scale the plan to adjust for the CPU and memory requirements of this live site. After it runs that AZCLI command, it then goes to the repository that's linked. It tries to find if there's an IAC file that might also be correlated to this change. And it finally is able to open up a GitHub issue that will then hand it off to GitHub Copilot to go ahead and make those changes. We can see here in this GitHub issue, we have all the incident context. We have the PagerDuty incident. We have the subscription, the Azure information. And it also is able to use the exact Azure live logs, as well as all the logs that came in from the live site, to make any recommendations for future changes. So I'm going to go ahead and hand it back to Mandy now to show what GitHub Copilot will do.
Great. All right, we'll switch back. OK, so we saw that the SRE agent opened the issue. And because we already have the Azure MCP server configured with the coding agent, they were able to assign that issue to the coding agent. The Azure MCP server was ready to pick it up and work with the coding agent to solve it. So what I have now is a PR that is actually making sure that the change that was identified and fixed to handle the issue, we're making sure that our infrastructure as code is updated to match any of the changes that were there for that remediation. So OK, so let's take a look. This is the PR. We can see, taking a look through it, that it was assigned to Copilot, and Copilot starts working. And then we can actually go into the session where Copilot was working and take a look at how the MCP was used. So this is the session where it was doing the work. We can see it's using the Azure MCP server. It's starting it up, and it begins working through understanding what it needs to do to fix this issue. And then we see here where it's calling out to get the bicep schema, update the bicep to update the infrastructure that match the fix that the SRE agent identified. So we've gone full circle through coding to maintaining, SRE agent, getting an issue, fixing it, opening that issue, and then using the Copilot agent and MCP server to keep everything up to date and in sync. So that is, I think, a really great full circle example of how all of these tools work together. So we will take one quick look through that again. Once again, when you're coding, you have your IDEs and the MCP server, building and maintaining the coding agent, operating the SRE agent, and all the amazing things that 𝗲𝗏 showed us. Everything that you saw today in all of the demos, you can try all of that out today. It's all available, ready for you to try. These are the links that you need to get going with it. So the SRE agent, this is info to get started. The Azure tools for VS Code, that will include the Azure MCP server as well as a bunch of other really great tools. You can also read about the MCP server standalone. And then the AI toolkit is another tool for VS Code that includes a lot of the agent building capabilities, model catalog, and ways that you might look at building your own agents. There's a ton of great sessions still to come. There's so much Ignite to be had. So definitely check these out, and you can check a lot of these on demand. And we just want to thank you for being here. We really appreciate it. Really appreciate you being here and enthusiastic. We would love your feedback. Let us know what was interesting. Let us know what we can do better. And we'll be hanging out for questions after we finish.
Thank you so much.